Hello everyone, my name is Chichen Huang. I'm an application engineer in CDC business unit in Maxim Integrated. I work on the Power over Ethernet products. As you know, Power over Ethernet power supply solution requires isolated converter like Flyback or forward converters to supply power to the downstream load. Today, I'm going to demonstrate our new developed dual-phase flyback topology that can output double power than traditional flyback can do. Now let's look at the demo board I'm going to present today. You can see two boards. The left one is the MAX15158 flyback dual-phase EV kit, and on the right one is a single-phase forward converter. Nowadays, the PoE power demands more and more power, which can be up to more than 50 watts. So single-phase flyback cannot support that high power because of the thermal stress issue. Single-phase is traditionally used, but for more than 50 watts power, it requires an EFD20 transformer with a very large volume. In addition to the transformer, there is a large output inductor here. But on this dual-phase flyback, we just need two EP13 plus flyback transformer. Each of them can output 25 watts. So the total output power can be easily up to 50 watts. Another benefit is our controller here on the back side. It has integrated active current control, which means these two-phase flyback are interleaved and can be current balanced. Okay, now let's look at the performance of this 15158 controlled dual-phase flyback. It can accept the input voltage range from 37 watts to 57 watts. And on this board, it's configured at 12 volts output, and it can output more than 4 amps current. Now let's connect it to the power supply. And connect the output to the electronic load. And now let's connect the probe at the output. Then we can observe the output waveform in the oscilloscope. And then we start the input voltage with the power supply. So as you can see, once the input power applies, then the Vout will power up to 12 volts. Of course, we can configure it at a different output voltage like 5 volts, 24 volts, or even up to 54 volts. And another waveform I want to show you is the interleaved switching waveform between these two phases in this dual-phase flyback converter. Now, we're going to see the switching waveforms, the drive signals of two phases. And if we increase the load current from 0 to 4 amps and open it, and you can see how the duty cycle changes. If we increase the load to 4 amps at the full load condition, we can see the dual-phase flyback are still working in a current balancing condition. These interleaved characteristics can increase the equivalent effective switching frequency and reduce the output voltage ripple. Then it can help us to reduce the output caps. Compared to the traditional forward converter, our new topology can reduce the thermal stress at high output power PoE applications. That's all my demonstration for the demo board. Thanks for watching.